So, good afternoon, everyone. Welcome to the final press conference of H 2020 DTOceanPlus project. My name is Mélusine Gaillard and I am the communication officer for the project. So today we want to leave plenty of room for the discussions. That's why we will have a short introduction given by Pablo Ruiz-Minguela, who is the project coordinator. And then we will show you a pre-recorded video to let you know what the software looks like. And then we will have around 40 minutes for the Q&A session. So the three panelists we have today to answer your question are from the DTOceanPlus team. So Pablo Ruiz-Minguela, who is the DTOceanPlus project coordinator and is head of wave energy at Tecnalia. Donald Noble, who is research associate at the University of Edinburgh. And João Formiga, who is head of renewable technologies area at EDP, which is the R&D center of Energias de Portugal. So now I will leave the floor to Pablo. Okay. Pablo, you should be able to share your screen now. Yeah, we can see your presentation. You on mute for now.
Okay, I think that you can see my screen. Thank you, you can hear me. Thank you, Mélusine, and thank you for the people watching us right now. I'm going to present briefly, outlined more or less, the work that we carried out in the DTOceanPlus project. This is an ambitious European funded project to accelerate the commercialization in the ocean energy sector. As Mélusine said, I'm acting as project coordinator and as I'm head of the wave energy at Tecnalia, which is a research center in the place located in the north of Spain. The project aims at developing and testing an advanced suite of tools, open source, for ocean energy system innovation, development, and deployment. These tools will have a medium-high maturity by the end of the project. We estimate this will be a TRL 6, which are tools demonstrated or software demonstrated in a relevant environment, and but there will be some remaining effort pending to bring this software into a fully commercial product. The project started in May 2018 and ran continuously through 40 months until this month, August, that it will come to an end with a total budget of 8 million euros. But this is not starting from scratch, it's a continued development of first generation tools that were developed in another European funded project, DTOcean, and also these tools are open source, but with restricted functionality also for wave and tidal energy arrays. But we are developing this new functionality and also providing demonstration through real projects from the industrial partners within the consortium. And as you may imagine, this challenging project is a result of a collaboration from a large number of partners. There were 16 partners from 7 European countries collaborating, plus 2 leading research laboratories from the US. Apart from Tecnalia, we count in Spain with an engineering consultancy and company, and also wave energy technology developer, IDOM. In Italy, we have a utility company, Enel Green Power. In Portugal, we have EDP, that is also an utility company, plus a research center, Wave Energy, Wave Energy Center in Portugal. In France, we have another research center, France Energie Marine, plus a lead software developer, Open Cascade, a tidal energy technology developer, Savella, and a certification body, Bureau Veritas. Up in the north, in the UK, we have also the participation of the University of Edinburgh, another research institution, the Energy System Catapult, plus 2 tidal energy technology developers, Nova Innovation and Nova Orbital Marine Power. And last but not least, in Denmark, we have the University of Aalborg and the second wave energy technology developer, CoPower. In the US, we all collaborated with the National Renewable Energy Laboratory and the Sandia National Labs, which are helping us to have an international adoption of the tools. The process we follow started with the identification of end user needs, and we counted with collaboration of the ocean energy sectors and our industrial partners, and we follow with the development of the numerical of the software tools for innovation stage gate deployment and assessment of wave energy and tidal systems, subsystems and devices. We integrated and thoroughly tested these tools. We are in fact finalizing that process with real world deployment in order to achieve that TRL6 open source software that I mentioned previously. So the industrial partners were part of the verification and validation activities. But the process doesn't end here because of the nature, open source nature. We are building an open source community for further development, optimization, and validation of new functionality. Alongside this main development process of the tools, we carried out market analysis activities of the ocean energy sector. This involved the identification of alternative markets, for instance, the analysis of market pull or push mechanisms, the development of proposal of new innovative business models, or the analysis of barriers and enablers for ocean energy, which are not non-technological barriers and enablers. What we have now produced is first and foremost this TRL6 open source software suite, associated documentation, and one global database that comes with the software. These tools also implements for the first time method to standardize the data formats and to enable communication among the different stakeholders in the ocean energy sector, what we call the digital representation for ocean energy systems. There is a great deal of public reports that are available on our website about development, testing, training material, dissemination, and data management, plus 5 reports specifically detailing the market analysis results for the ocean energy sector. Our work also produced 7 open access peer-reviewed scientific publications, and along the global database, we produced 3 public open source data sets in order to give further visibility to the components, vessels, etc., information that is required in order to make ocean energy designs. The software suite of design tools is a modular system, but the main blocks are depicted here in this slide. We produce a brand new tool for concept creation, selection, and design, what we call the structure innovation tool. There is another brand new tool, the stage gate tool, that is a tool for to assist decision making, and it uses metrics to measure, assess, and guide technology development. There are also the deployment design tools for more mature technologies that are new and upgraded versions of the former DTOcean tools that support the optimal device and array development. This involves 7 modules, site machine characterization, that define the scope of the project, energy capture that helps design the layout of the devices in a farm, energy transformation to design the power takeoff, energy delivery, to design the connection, electrical connection of the devices onshore, the station keeping that does the same for the mooring and foundations, and the logistics and marine operations to design all of the activities that should be done for the installation, operation, maintenance, and the commissioning of the farm. Finally, there are also the assessment tools. This is the 4 type of tools that are upgraded versions of the tools that were present also in the DTOcean DTOcean first generation, that provide objective information to the developer or investors on the suitability of the technology and project. And they are grouped in 4 categories. One for the all energy aspects, system performance and energy yield, another for the cost, system lifetime costs. The others relate the reliability, availability, maintainability, and survivability aspects of the technologies. And finally, the environmental and social acceptance that produce information for quantifying impacts and benefits in terms of social, economic, environmental issues. These tools are supported, as I said, by underlying digital models and a global database. So this was all I wanted to present, and I pass to the floor to Melusine for the following video.
Thank you very much, Pablo. So before showing you the video, do not hesitate to write your question in the chat, and we will go back to them after this very short pre-recorded video.
Yes, hello everyone. So I'm Frederic from Open Cascade. Can you see my screen?
Yes, perfect, Frederic.
This one. So yes, as Donald explained, so the main application runs in a browser. So here you can see I'm using Chrome, and by entering this URL, you will access to the main application. So then you can start to log in. And when you log in, then first you will arrive to the dashboard where you can access the main features of the application. So basically to manage project, to access catalogs, logs is something that is not implemented yet, and documentation. So documentation, you can access directly full documentation of the project, of all modules. Catalogs, as Donald explained, is a specific modules where you can access generic data that can be managed by several, that can be used in one or several modules. For example, a list of cables and so on, and you can extend this list by adding new values or editing existing ones. And then sorry. And then what will interest you more is the project. So here, a project is the main concept of the application. It regroups all the information that are related to your real project. So you start by giving a name. You can add a picture or a logo if you have one. You need to define the type of technology you want to work with, so wave or tidal. Type of device, in fact, we will remove that because it will be asked by a specific module. So then the project is created, and now I can open it. If you deploy, if you have several users, so you can share your project with your colleagues, for example. So here I can register this user as a co-editor of this project. And then you can define the study. So inside the project, you can have one or several studies, and a study corresponds to a run of one or several tools. Basically, you can try different design on an assessment to check what is best for your project. So there are two tabs. Each one corresponds to one type of study. The first one is standalone. So basically, it means that you just want to use one tool. You have a very specific need, and or you want a quick to make a quick design, or have a quick to run some tools to just have a quick view of a project. And design assessment study is where you can run all the tools together. So first, you will need to select to use the first two tools, which are site and machine. So you can select an existing site if you already characterize a site for another project, for example, or same for machine. So you can either select one or create an existing one. For example, I will for site I will create a new site, and we will see later with Yuan or Nicola how it works. And for machine, I can select an existing one, for example. And once I have done this, I can now create a study for design and assess. So I can put a short description for example, initial design. And then I can open this study, and here now I have all the different tools which are available, and I can start opening those tools. So I need to instantiate those tools, so I can create, for example, something for the energy capture module. So here I can use default values, and then now I can open this tool, and then I can continue by doing the same for other modules. So create an entity, and then I will. So for example, now I can open the site. So now it opens the site tools that we will speak now with Yuan and Nicola.
So we are back now for the Q&A session. Can the panelists join me with their webcam? Okay. So we have several questions. So maybe the first one will be for you, Donald, about the potential users of these tools. Who are they?
I think Donald is muted.
Donald.
Sorry, I was muted on my other phone as well. So hopefully my internet connection will hold up. It was a little bit jittery earlier, but yeah. In terms of the main users, we kind of identified 3 groups in terms of technology developers. Sorry, my brain has just gone blank. And I've lost my notes. Sorry, excuse me 1 second. Sorry, yes, I'll start that again. We identified 3 main categories: the technology developers, i.e. people who are focusing on their specific device or technology that they are trying to develop. For example, a wave energy developer like Core Power, or a tidal developer like Nova Innovation. Some of those technology developers at the moment are also project developers who are looking at developing sites, but there may also be project developers in future who are buying in technologies. And then there are the public and private investors, and these kind of have a similar understanding that their requirements are looking at the financial implications of how to develop the sector. And then there also be, academics using the tools in terms of the research community, and they will largely be kind of using the tools in one of those 3 use cases. They will be acting in the scope of a technology developer, or a project developer, or a private investor, for example. And at the start, at this point in the sector, it's probably smaller enterprises that are working on this, but hopefully in future we'll see larger companies getting involved. Although at the moment we do have the likes of EDP New as with João on the call. So yes, hopefully that answers the question.
Thank you very much, Donald. We have another question, maybe for Pablo, which says, what are the main uses identified for these tools, and what is the added value of these tools compared to what already exists?
Yeah, thank you, Melusine. I think there are 2 questions in one, but I will start with the main uses of the tools. There are 3 main uses: design, assess, and innovate. And there are many examples I can give you about the detailed use modes, but I will name just a few. For the innovation, it could be creating new or improving an array, a device, or a subsystem concept, identifying and enabling technologies, quantifying the challenges of finding attractive areas of innovation. Regarding the assessment of designs, I think it is important that the tools allow to assess what the stage of technology is, including not only devices but also the subsystems, which helps in order to assist in the investment decisions and providing evidence for the marketing, certification, or investment. Also, assessing designs will involve how a device or technology performs at different locations. Yeah. For the design part, I think the tools allow optimization of the size of an array and the balance of plant for a specific device allocation, and also the planning of installation and O&M activities. Yes, these are some of the use modes that can be developed through the use of the DTOceanPlus tools. Regarding the second part of the question, the added value, I think it is important that we have produced a modular but integrated open source solution. So it's a single solution that has many kind of components that can be used either in a standalone mode or an integrated form. This hopefully will help all of the use modes I mentioned before to reduce the technical and financial risks. The tools that you have been hearing from us has some structure innovation process embedded and also sound and stages gate guidance for the technologies under development. The optimization of designs is another added value. And finally, I think we also implemented the use of a standard data model for effective communication, and that this tool has been validated with data from real case technology projects. This could be the added value and the main use of tools.
Thank you, Pablo. We have let's say complementary questions asking, can some of these tools be used individually? Or maybe Donald, you want to answer it? I don't know.
Sorry, Melvin, could you please repeat the question? My internet maybe dropped out a little bit there.
As well.
Sure. Can some of these tools can be used individually?
Yes, so at the moment we have developed a suite of tools, and they are developed in a modular manner. So each tool can be used independently. The value, however, is using them as an integrated suite, because the data requirements for some of the later tools depend on the outputs and calculations of the earlier tools in the suite. So, for example, understanding how much energy would be delivered, that would be calculated first in the energy capture module, which depends on the site characterization of the data, and then you would have the amount of energy that's transformed by the power takeoff and control subsystems, and so that affects the amount of energy that would be delivered to shore. So you can run them independently, and we have developed them to do that, but I think the value is to run the integrated suite.
Okay, thank you, Donald. We have another interesting questions asking for the sites. Can the tools be used for different sites around the world?
I can maybe answer that one as well. That the main focus of the tools and the data that we've provided with the tools is European waters, and specifically making use of some data from the Omer project in France. And so there's a lot of open source data available on waves and currents around the French waters, which we've made use of. But with your own data on both resource, on ports and harbors, etc., then the tools can be run anywhere around the world. And we have a core bathymetry of the whole world included within the site characterization module.
Okay, thank you very much, Donald. We have another question, probably for João. How did you proceed with the demonstration phase with real scenarios?
So, hi everyone, thank you for the invitation, Magazine and all the colleagues. Well, to start, the real case scenarios were defined well in an earlier phase of the project during the work package 2 in deliverable 2.3, in this case, the demonstration methodologies. And then they were refined a little bit down the road with a detailed description of the demonstration scenarios, where the objectives, the scope, and the description of the scenarios were detailed. Based on these interactions, we came with the validation scenarios, 6 of them, that were outlined and deployed to cover basically 2 types of technologies, both wave and tidal stream, and also different levels of aggregation, either by array level, device level, or at subsystem level. And for the type of design tool, basically either the structure innovation tool, the stage gate one, or the deployment and assessment. Among the consortium, we had 7 entities that validated these tools. And as I mentioned, so these 6 validation scenarios were divided in, well, the first one at the array aggregation level. We for the deployment design, we had IDEOM testing their array at BIMAP site. Then for the tidal technology, we tested the deployment design tool. Basically, we had Nova, Sabella, and Orbital testing their arrays in existing projects, testing with the DTOceanPlus tools. Then for the device, we had Core Power testing their CPO that will be installed also here in Portugal, in Negociadora, testing the structured innovation tool. And as for the tidal stream, we had Orbital and Sabella testing the stage gate tool for their Orbital O2 and Sabella D12. On the subsystem level, also Core Power tested their CPO, the stage gates actually with the PTO of Core Power, and then for the tidal, Orbital tested the structured innovation tool using the Orbital O2 connector subsystem. And basically, I think that this summarizes the validation tasks and what we did to prove or to demonstrate the tools in real scenarios.
Thank you, João. I have another question. Maybe you partly answered, but yeah, it's maybe for you and so for Donald. Does the tool use real test data like tank test data to assess the technologies?
I can jump in on that one. That the stage gate module within the suite, it has a series of questions to assess the status of technology development, and part of that is to say, have you done activities such as tank testing at a certain level, or testing of a particular component? If you're also using that within a technology assessment process, then you could put in some justification of those tank test results within your response to the questions that are asked in the stage gate, and they could be sent to an assessor. And this is something that has happened within the Wave Energy Scotland technology development programs that are running, and is likely to happen in the Europe Wave projects that are upcoming. So these results are not directly used within the tool, but they help justify the decisions and made within the stage gate process.
Thank you very much, Donald. We have another question, probably for João. What is the feedback from industrial partners, of this suite of tools? And have you already received expressions of interest from potential users?
Well, probably starting with the latter, with the expressions of interest from potential user. Despite this being an ongoing work, ending by the end of this month, there has already been some discussions, and some consortium partners do indeed have future plans to continue either developing or using the DTOceanPlus suite of tools or specific modules. I can say that from our side, for instance, we have interest in exploring the stage gate tool, the site characterization, and the logistics O&M models, but also the environmental and social acceptance model from the assessment design tools, for instance, because apart from the added value that these tools have, obviously for the wave and tide cells and for the tidal, we see that there's a lot of capabilities for these tools to be used also in the mainstream offshore wind, in which EDP is as a major role, as you know. So this is also our perspective. In terms of other research projects, we have been contacted by some, namely Imagine, this H2020 project that will develop and demonstrate an innovative PTO for wave energy applications, but also the Valid project, also on H2021, to create a hybrid test facility that encompasses several wave energy technologies, and lastly but not least, the impact project that will design and manufacture 2 novel test rigs covering up to 75% of the wave energy converter subsystems. So I believe that this covers, in the sense that there have been some expressions of interest from the industry perspective, and from our perspective, this range of tools is very interesting to be explored in the future. So yeah, I think that's more or less it.
Thank you very much, João, for this interesting feedback. We have another question asking, do you see investors using the suite of tools to make decisions? Maybe for Pablo or Donald.
Yeah, I will take this question, Melusine. Well, the design, as Donald has indicated, I think there is one group of users that are public and private investors. So the tools are designed with in mind these kind of users. In fact, one of the tools, the stage gate tool, has 2 modes: the applicant mode and the assessor mode. In the applicant mode, applicants submit a kind of assessment of their technologies, and then in the assessor mode, these are evaluated, compared, and according to the results, design decision, investment or development decisions are taken. So this is one tool that can be directly used by these investors. When we come to the design, the deployment and assessment tools, I think these tools are a bit more complex. And although the information that outcomes these the use of the tools is very relevant for these investors, the use of the tool should be along with the, say, technology developer or project developer, yeah, because a lot of information is required, and obviously transferring that information to the investor and processing that information is probably not the best or the most efficient manner.
Thank you very much, Pablo. We have another question about a group, let's say a group of questions. Where can these tools and associated documentation be downloaded? And another in the same idea, would universities get access to the tools to use for their research in ocean energy? Maybe Donald?
Yes, Melusine. I think what we've been doing within the project is developing these tools within a private repository just within the consortium, but on Tuesday, the 31st next week, we will make this available, and it will be hosted on the GitLab platform, where people can download the tools. They can view the source code to understand in a lot of detail how they work. The documentation will also be included within the GitLab platform, so it is actually effectively part of the code of the tools alongside that. And then it creates a nice web page where you can browse that. The links to the GitLab repository will be on the DTOceanPlus.eu website, and we will share them widely on social media. And yes, the universities would definitely get access. Everyone will have free access to download these tools and install them and run them. And one thing maybe to make clear at this stage is, while we have progressed massively the functionality of the suite of tools within the DTOceanPlus project, the software is still in development, although we have reached this TRL of 6, as Pablo discussed earlier. So there will still be points to resolve beyond the end of the project.
Okay, thank you, Donald. The next question are related to what you just answered. It's how much effort do you think is required to have a commercial ready suite of tools? And a related one is, when do you think these tools could reach a TRL of 8?
Yeah, I will take that question. It much depends on the level of resources we're able to attract as a consortium. Obviously, the open source community can attract further people that are able to develop new functionality, test or validate the tools, and this will be greatly thanked or appreciated. But we estimate that we need to cover at least 2 critical steps. One is that we implement the first implementation of DTOceanPlus tools on a large scale project, and this will allow us to achieve, say, a TRL 7, and also to implement some technical improvements to enable further usability of the tools, more independent or less assisted use of the tools, more robust tools. And secondly, we need to cover or to add functionality tested in operational scenarios with several adopters of the DTOceanPlus in the project pipelines, and which will lead us to the successful operational experience and maintenance of software capabilities being deployed. That is also an important part. So all in all, I think we estimate between 1 or 2 years until we get that level of maturity. The effort obviously is dependent on the resources in-house or the contributions of the open source community.
Thank you very much, Pablo. We have another question asking, do you need to be a wave or tidal energy expert to use the suite of tools? Maybe Donald, you want to answer?
Sorry, I lost that again.
Ah, okay.
Can you repeat the question?
Yeah. Do you need to be a wave or tidal energy expert to use the suite of tools?
I don't think you need specifically to be an expert in wave or tidal energy to use the tools. We have tried to make the range of inputs and parameters that are needed as simple as possible, although it is a very complex field. The the tools are documented to explain how they work, but always throughout the process we were designing these for an informed user, i.e. somebody who understands the technical design decisions that are being made. They are not plug and play type technology. You know, you can't just put in a set of random numbers and expect to get a brand new concept for a wave energy converter. If it was that simple, then wave energy would have been commercialized already. It is a hard process to understand this design, so it certainly needs some form of technical background, but not. Hopefully, you don't have to be an expert. That, you know, a student on a course on renewable energy could go through this with an example and, you know, come up with some useful results out of that.
Thank you, Donald. We have another question. It may be for you again. It's about the market analysis that was carried out during the project. Can you tell us a bit more about what are the main conclusions?
Yes, so there was a work package which was led by the University of Edinburgh, but had contributions from, you know, the entire consortium really, and this was looking at the market analysis of ocean energy. You know, for there to be a need for design tools for ocean energy, there also needs to be a market for ocean energy. So although it's not directly linked to the software, it is linked to the use of the software in future. So this work package had 5 reports, as Pablo alluded to earlier. The first of these looked at the analysis of potential markets. These were both, you know, the market for grid power, which, you know, is probably the long-term goal for many of the people working in the sector. But we also looked into niche or alternative markets, such as looking at building alongside aquaculture, looking at powering offshore structures with wave and tidal energy. So that's sort of built on some of the work done by the US Department of Energy in their Powering the Blue Economy report, and was updated. And yeah, you know, we also had a report looking at the European supply chain, trying to understand where there are scope for improvements there, where the European supply chain can be built up to support, you know, an ongoing sector developing. A piece of work that I was heavily involved with was the feasibility and cost benefit analysis, and this was really looking at the way to develop funding to develop ocean energy. So looking at the mix of funding policies that can be enabled by governments and the costs of developing or the cost of commercializing wave and tidal energy. And we found that it was really important to have a mix of both innovation programs, similar to, you know, the Horizon Europe or Horizon 2020 or Wave Energy Scotland, but also to have a clear market pool mechanism, a tariff, to allow subsidized deployment, because if there's no deployment, there's no market, and that's really important. And then the final 2 reports were looking at business models, and that built on the potential markets study, and tried to look at how can developers who have maybe slightly higher costs than would be required to supply grid power, can they look at these alternative markets? And then the final piece of work looked at, you know, what are the legal and political frameworks, and whether these were enablers or barriers to the sector, and tried to summarize that through a questionnaire of various parties involved in the sector. So those 5 reports are all available on the DTOceanPlus website, and there are also 2 journal papers that have come out of this work. Again, they are linked from the DTOceanPlus website.
Thank you very much, Donald, for this summary of all that work that was carried out in this work package. We have the time for just one more question, maybe for you, Pablo. How did you structure the work so that developers from different backgrounds and countries work efficiently and in a coordinated way?
Yeah, well, I think I first must acknowledge that I counted with a very high quality, proactive set of partners and members that were very willing and open for collaboration. So that's key, and it was leading us to the good set of results. On top of that, of this, we established a formal management structure with some governing bodies, General Assembly, bringing up all the partners, the project steering committee meeting in order to identify regularly the needs for the priorities or scientific need, technological needs, and taking strategic decisions. And also we have a strategic advisory board that consisted of external partners, also the industrial partners and the US partners that gave us regularly, at least 1 year, some feedback. We presented them with the partial results, and they produced some recommendations for us to continue focusing on the most impactful results. And more at the more practical level, I think we implemented what we call a technical working group to better coordinate the cross-cutting technical activities, because software development was happening in different sites by different partners, and with such a complex tool, it was difficult sometimes to have a smooth or seamless integration of activities without conflicts. These technical working groups run every 1 or 2 weeks during most of the project lifetime, and demonstrated to be very useful in order to add consistency to the different work packages and tasks.
Okay, thank you very much, Pablo, for this very nice feedback. So I think we are at the end of the press conference. Thank you, Pablo, Donald, and João for being here and answering the questions. Thank you also for the participants to attend this press conference. And thank you all for the very interesting discussions. We hope the answers that were given will be useful for you. And if you need any additional information, you can leave a message using the project website. If you want more technical information, you can also attend the final virtual technical workshop on the 31st of August, so next Tuesday, sorry. And registration is already open on the project website. So thank you all again for being there, and have a nice day.